Now that you have a basic idea of the math which we're going to use in the Solow model, I think the time has come to set up the Solow model. So just a bit of background to tie this up with everything you've learned in macroeconomics other than this. In macroeconomics, you know that in the long run, the full employment level of output is always going to be achieved because wages and prices are flexible in the long run, which means you have a vertical AS curve. Now we are going into the very long run, which is growth theory. What changes then in growth theory? In growth theory, you continue to exist in the long run in the sense that output is always at full employment level. But what the full employment level of output itself is keeps changing, right? So remember, your resources are fully employed in the Solow model, but Y bar or Y star grows over time. Why does it grow? There are three main reasons why Y bar may grow. So let's look at it. Y bar grows. The first reason is that K grows, right? So till your long run macroeconomics, including short run and medium run, you assumed capital to be fixed. This was usually implicit because when you studied the labor market, you probably think of production as Y equals F of L. The implicit assumption here is that K is fixed and so only L determines output. So if K grows over time, the full employment level of output at L bar or L star also obviously grows. The second reason is that L bar grows. Now understand, L bar in a given economy is fixed by labor supply and labor demand, right? That itself doesn't change. The natural rate of unemployment doesn't change. What changes is the size of the labor force. So labor force, this grows. Why? Because population grows. In Solow, you assume that labor force participation is constant while population grows. And so your L bar grows. So for the same level of natural level of unemployment, the total L employed is larger and so Y bar is larger. 3. Productivity. For the same K and L, you might have higher output. Now, in the Solow model, how are these three things treated? Productivity growth is exogenous. It just happens. You don't know how it happens. In later models, this was endogenized. This is in fact a weakness of the Solow model, but it is exogenous in the Solow model itself. How does L bar grow? So, labor force participation rate is constant, right? But population grows at fixed rate, right? So L dot by L equals N, or you might write L is equal to L0 ENT. This is what happens in the Solow model. And this is endogenous in the Solow model, the growth rate of capital. Okay? So we study in the Solow model long run growth through these three parts. Let's then look at some assumptions, right? These are also assumptions, by the way, obviously, of the Solow model. Let's look at the production function of the Solow model. You assume certain things about this function in order to get some certain results. You'll see all of this later on. But what are these assumptions? So in the basic Solow model, without exogenous technological growth, Y is, of course, a function of capital and labor. Okay. A whole host of assumptions on this production function is made. You should know it very well. Right? So these are all the assumptions. What are these assumptions on the production function itself? Fi is positive. So MP is positive of both factors. Fii is negative, diminishing returns to both of these factors. Fij is positive for I naught j, which means that as labor increases, marginal product of capital for a given level of capital increases. So more labor means your machines are more productive, more capital means your workers are more productive. Then you have F0L equals Fk0 equals 0. Right? This is called essentiality of factors, which means without L or K you cannot produce any output at all. Right? The next thing you assume, and this is a very crucial assumption. By the way, this gives you a concave shape in some senses. Okay, actually I'm not going to write this because it's not necessarily true. We'll see what I mean by concavity here later on. Okay, so you have CRS. What does CRS mean? Constant returns to scale. So F lambda K lambda L is lambda FKL. So if I double both capital and labor, your output is double. And this implies by Euler's theorem that KFK plus FL LFL equals Y. Okay? Alright. So these are the assumptions on the production function. You'll see why this is important later on. The next assumption, which you're going to combine with this production function, is perfect comp. Right? So there's perfect competition in the markets. This in both the factor and the product markets. Now, in any macro model, just to give you a taste of what we are doing, you have a representative agent and a household and a representative firm, and you have a representative good, Y. Right? So there's just one of each. But since it's homogeneous, all consumers, all firms are the same, all goods are essentially, there's some composite good of sorts, they're all the same. So you take a representational firm and you profit maximize here. So understand that the agents in this macro model are still working optimally. So this firm which exists, this representative firm, is also profit maximizing. So the profit function is this, right? R of K, W of L at any given point in time. So when you profit maximize, you're going to have P F K equal minus R equals 0 and P F L minus W equals 0. Right? So Fk equals W by, R by P, Fl equals W by P. So this is real rental and this is real wage. This is true for the given economy. And very often you just assume P equals 1 as a numeraire and you really get the same results. But yeah, I mean, from perfect competition, you derive this. The second thing you derive, which essentially flows from this, combine this with this equation. What do you get? Since Fk equals this, you get K R by P plus L W by P equals Y, which implies Py equals Rk plus WL, which implies profit is 0. So CRS combined with perfect competition imply that profit is 0. Now this is very crucial, because this tells you what the real wage and real rental of the economy is in a given year. So we are still dealing with the assumptions of the Solow model. The next one being, and we are going to come to using these assumptions to get something useful very soon, but this is all just the setup of the Solow model, as indeed I have titled the video. So the next thing is the assumption on consumer behavior. So usually, as I told you, macro models assume a representative consumer who is utility maximizing. So here, this is another weakness, in fact, of the Solow model. You don't deal with the consumer at all. You just assume a type of behavior, which is that they save S proportion of income, right? So savings is equal to SY, which comes obviously from C being proportional to output. So this is again an assumption on consumer behavior. This is a weakness of the Solow model. In fact, it is a weakness of any Keynesian models before this as well. If you recall from your normal macroeconomics, you just assume C is equal to C bar plus CY or CY minus D. You just assume consumer behavior. You don't actually maximize. So this is the next assumption of the Solow model. The final critical, this is not an assumption actually, this is a result from, again, standard macro, which is that S is equal to I, and constant fraction of capital depreciates each year. I'm using each year very loosely here. To be precise, since we are dealing with a continuous time Solow model, this depreciation is happening instantaneously at all points in time. But you can just think of it as a year to ease your understanding of the model.